All furnaces require a supply of air for proper operation. A furnace's air system ensures that the correct amount of air is delivered to where it's needed for proper combustion. The gases produced during combustion transfer heat to the furnace tubes and then flow up the stack. The flow of air and combustion gases through a furnace is generally known as draft. Furnaces are often identified by the type of draft that they provide. For example, two common types of furnaces are forced draft and natural draft. A natural draft furnace works much like a fireplace and a chimney. Heat from the fire in a fireplace warms the air in it. The heated air in the fireplace is lighter than the cooler air outside, so it rises through the chimney. This reduces the pressure inside the fireplace. As the hot air rises, it's replaced by cooler, heavier air in the fireplace, and the process continues. In a natural draft furnace, the hot combustion gases, which are lighter than the outside air, rise up the stack and create a lower pressure in the furnace. As this occurs, cooler, heavier air from outside the furnace is drawn into the burners through the air registers. Airflow through a furnace is produced by a difference in pressure. In an operating natural draft furnace, the pressure inside the furnace is less than the atmospheric pressure outside. As a general rule, as the difference in pressures increases, the amount of draft in the furnace also increases. The pressures in various areas of a furnace are typically measured by instruments called draft gauges. Draft gauges commonly indicate pressure measurements in units of inches of water. These gauges are used to determine the flow of air and combustion gases through the furnace. In a natural draft furnace, the height of the stack affects the amount of draft that can be produced. In general, if all other airflow conditions are equal, the taller the stack, the greater the draft. This is because a taller stack creates a greater difference in pressure. Often, the amount of draft must be adjusted for proper operation of the furnace. Since the height of the stack cannot be adjusted, another technique is used. In some furnaces, the draft is controlled by the position of a damper inside the stack. Changing the position of the damper makes the outlet for the combustion gases larger or smaller. As the outlet gets smaller, draft decreases. As the outlet gets larger, draft increases. Air and combustion gases are moved through forced draft furnaces by fans. This is a simplified illustration of a forced draft furnace. A fan, called a forced draft fan, draws air from the atmosphere and forces it into the furnace. On this furnace, the burners are mounted along one wall. The combustion gases flow through the furnace and then out through the stack. In a forced draft furnace, airflow is controlled by coordinating the positions and operation of the stack damper, the burner registers, and the fan. Some forced draft fans have dampers or louvers on the discharge side of the fan. These dampers can be opened or closed to allow more or less air to flow into the furnace. On other types of forced draft fans, the dampers are located on the inlet side. Adjusting the inlet dampers increases or decreases the amount of air that is admitted to the fan and into the furnace. Another type of furnace is a balanced draft furnace. A balanced draft furnace is similar to a forced draft furnace, but it has another fan in addition to the forced draft fan. The second fan is called an induced draft fan. It is located in the flow path of the combustion gases between the furnace and the stack. So, in a balanced draft furnace, one fan provides air for the burners, and the other fan removes the combustion gases.